Hello everyone. In this video we'll discuss about uniform distribution. So we'll see what is a uniform distribution. So if I'm drawing a card from a pack of 52 cards, and we know that there are four faces, that is, one is hearts, clubs, spades and diamonds. So if I have to pick a card from the pack of cards, it is a uniform distribution irrespective of any face. If I impose a condition, like if I have to take a 12 of king of hearts, then a condition is imposed there, that is not a uniform distribution. Like if I look into one more example, like if I'm standing in the corner of a street and I'm passing a 100 rupee note to whoever passes by, whoever walks by me, and I'm giving 100 rupees to irrespective of gender, height, age, right? Suppose if that is an uniform distribution, so whoever is passing by me is getting a 100 rupee note. But if I impose a condition like the person should be a woman, or the person should be of so and so height, then here when I'm imposing a condition, it is not a uniform distribution. So that is why the uniform distribution is defined in the interval AB, and it is given by a constant k. That is, in the interval A and B, the value is going to be constant, right? And this uniform distribution can be discrete and continuous, whereas here we are discussing about a continuous distribution because we are taking the interval between A and B. Now since f of x is defined as k in the interval A and B, we'll find out what is k now. And we already, as discussed earlier, we know a function is said to be a probability density function if integral of f of x between limits minus infinity and infinity will be equal to 1. So same way here, f of x is given as k and limits are given as a and b. So what we'll have? So limits between a to b, and f of x is defined by k. Right? Now solving, what we'll have? So this will give us, imply k into integral of 1 with respect to x will dx will be x between limits a and b is equal to 1. Now we'll simplify this. So substituting, what we'll have? This imply k into upper limit is b and lower limit is a. So k into b minus a is equal to 1. So this will give us what? K is equal to 1 by b minus a, provided b is always greater than a, because k cannot be negative, right? So now we'll define the distribution again. So the distribution is given by so the probability distribution is defined by f of x equal to 1 by b minus a between interval a less than x less than b and 0 elsewhere. Right. After we see the distribution is f of x is given by 1 by b minus a between the interval a and b, we have to look into we have to remember 2 points here. One is a and b are the parameters of the uniform distribution, and one more is that the distribution is also known as a rectangular distribution, because here y equal to f of x is described in a describes a rectangle over the x-axis between the interval a and b. So in this graph we see that it is in a rectangular shape, that is why we say this as a rectangular distribution, and it is defined between the interval a to b, and it is constancy, it remains constant in the interval a and b. And here we have seen the distribution as 1 by b minus a, f of x is defined as 1 by b minus a, so here it is 1 by b minus a, and this interval is ab. So since it looks as a rectangular form, this is also known as rectangular distribution. Now we'll see what is mean and variance of uniform distribution. Now we'll see what is mean and variance of the uniform distribution. Mean is given by, we already know in the previous video as discussed, mean is given for continuous distribution as integral of x into f of x dx between limits minus infinity and infinity, right? So this is equal to integral limits from a to b, and we know x is f of x is given by 1 by b minus a dx, right? Uniform distribution is defined as 1 by b minus a in the interval a and b. Now we'll integrate this. So this is equal to 1 by b minus a, and integral of x is x square by 2 between limits a and b. Now simplifying, this will be equal to 1 by 2 into b minus a, and here apply the lower limit and upper limit, so b square minus a square. So simplifying this, what we'll have, so this is equal to 1 by 2, this will be 1 by 2 into b minus a, and numerator we can write b square minus a square as b plus a into b minus a, so which will get cancelled, and mean of uniform distribution is given by b plus a by 2. So mean of uniform distribution is b plus a by 2. Now we'll see what is variance of the distribution. So variance is given by, as discussed earlier, so variance is given by integral from minus infinity to infinity x square f of x dx minus mu square, right? So this is equal to, and we know the uniform distribution is defined as 1 by b minus a between limits a and b, so limits a to b x square into 1 by b minus a dx minus mu square. So as discussed, as we have seen, mu is given by b plus a by 2. So substituting, what we have is minus b plus a by 2 whole square. Right. Now we'll simplify this and find the variance. So this is equal to 1 by b minus a is constant, and integral of x square is x cube by 3 between limits a to b minus, and here we'll have this as minus of b square plus a square plus 2ab by 4, and here substituting the limits, we'll have b cube minus a cube by 3 into b minus a minus b square plus a square plus 2ab by 4. Now we'll solve this. So this is equal to 1 by 3 of, here b cube minus a cube can be written as b minus a into b square plus ab plus a square by b minus a minus b square plus a square plus 2ab by 4. So here this b minus a will get cancelled here, and on simplifying that is simplifying b square plus ab plus a square by 3 minus b square plus a square plus 2ab by 4. This will be equal to b minus a whole square by 12. So the variance is given by b minus a whole square by 12. So the uniform distribution f of x is defined as 1 by b minus a between limits 1 by b minus a between limits a and b, 0 elsewhere, and mean is given by a plus b by 2, and variance is given by b minus a whole square by 12. Now we'll see what is the cumulative distribution of uniform distribution. Cumulative distribution f of x is given by this. Then how we got this one? As discussed in the previous videos, what is f of x given by? F of x is given by the cumulative distribution f of x is defined as probability of x less than or equal to x. That means minus infinity to x f of x dx. Now taking here in this one, we will take f of x as what? 1 by b minus a between limits a to b, a to x, f of x dx. And what is f of x here? F of x is 1. So we have this as here we have f of x is 1 by b minus a as we have seen. So this will be equal to minus infinity to lower limit will be right. So f of x is given by integral of f of x between minus infinity to x f dx. Now here the lower limit is a, right, and upper limit will take it as x, and f of x is given by 1 by b minus a dx. So this is equal to 1 by b minus a x between limits a and x. So simplifying this, what we will have? X minus a by b minus a, x minus a by b minus a. So that is why the cumulative distribution f of x is defined by x minus a by b minus a between limits a and b, and 0 between minus infinity and a, and like discussed earlier, always this will be 1 between b and infinity. Thank you.